I did all of that with a Raspberry Pi. Welcome to a super spooky episode of NetworkChuck. In this video, I'm gonna show you how to build a Raspberry Pi haunted house. And all you'll need is a simple Halloween prop, some Raspberry Pi magic, and a little bit of Python code. And what I'm gonna show you is nuts. You'll trigger with motion, start recording with a Pi camera, and then scare the living daylights out of your victim. And if you have a little bit of extra coffee in your cup, I'm gonna show you how to go a bit scary, because I found a website with legit haunted house props. And combined with the Raspberry Pi, I feel sorry for my trick-or-treaters. But I'm giving full-size candy bars. They have to earn it. Boo! Did I scare you? Boo! Did I scare you? Bah! Bah! So stupid. And of course, you gotta stay tuned for some excellent scare footage. Because you know I scared my family and my friends, and pretty much anyone I could scare, I scared them.
Where's the candy? Right here.
It's in the bowl.
Right there.
Now, do you want to hear a real scary story? Once upon a time, there was a beardless man. He knew nothing about IT. Not only that, he was stuck in a dead-end job selling toilets. He told himself day after day, I'm going to buy IT training. I'm going to study. I'm gonna get a better job, but he never did. Excuse after excuse. He's selling toilets to this day, and he still has no beard. Now, thankfully, the end of that story was made up. The beardless man started studying for IT certifications, got his A+ CCNA, and became a happy, bearded IT engineer, making a ton of money. So don't let that scary story be your story. You can start studying right now and get IT certifications that will change your life, open up jobs with IT Pro TV. They are the sponsor of today's video, and they are here to make sure that your life isn't a scary story. Get your A+, CCNA, AWS, and hacking stuff. They got everything. And it's training that won't put you to sleep. It won't make you a zombie. And they also have labs and practice exams to make sure you actually know your stuff. So check it out, link below. If you use my code NetworkChuck, you'll get 30% off forever. Now here's everything you need to do this, with the varying levels of spookiness, going from spookiness level 1, level 2, and level 3. I'll show you extreme later. Now before we dive in, let me show you how this is gonna work. Because when I found out Raspberry Pis could do this, this blew my mind, opened up a whole new world. So let me find a Halloween prop. Oh. My little buddy here. Now you'll notice on these animatronic Halloween props, they'll often have a try me button, which the button on this one has been ripped off by my kids. They're animals. But what I want you to go ahead and do is rip off the try me button. Cut it, cut the wire. And you'll notice there are 2 wires. And the way these props are activated is by touching those 2 wires together or creating a short like this. There he goes. For larger animatronics, they probably won't have a try me button, like this scarecrow behind me, but instead they'll have an 1/8" jack hole port thing where you can plug in a step pad, which those are pretty cheap. And if you get one of those step pads and you rip off the pad like I've done here, you'll see the same kind of thing. 2 wires that when touched together will create a short and activate your prop. So now we have to figure out some way for our Raspberry Pi to trigger that prop, to make those 2 wires touch. And that is where our relay comes in. The way the relay works is really simple. On the relay, you'll put one of the wires inside one of the little relay holes. I'm sure there's a technical term for it. I don't know what it is. And you'll put the other wire in the other hole. And when triggered, the relay will actually touch those wires together, triggering our prop. And this is all controlled via Python on the Raspberry Pi. It's amazing. Now, for those of you who don't have a relay or a Halloween prop, that's cool. You can still do this. All you'll need is some computer speakers that just wire up to the audio jack on the Raspberry Pi, and we can trigger a spooky sound like this. Now the main way I'm gonna show you how to trigger these props and the scary sound if you wanna do that is with a motion sensor like this. We'll wire this motion sensor up to the GPIO pins on our Raspberry Pi, which are all those little pokey spiny thingies on your Raspberry Pi that you always ignore, but now we're gonna use because they're amazing. By the way, this is not an accurate wiring, I'm just drawing, okay, just relax. So this motion sensor will obviously sense motion, send that information to the Raspberry Pi, and the Raspberry Pi will kick off the Halloween prop. Now again, if you don't have this, I'll show you how to trigger your Raspberry Pi to do whatever you want it to do with your phone. Where's my phone? With your phone, and it's so simple and awesome. Now, level 1 is spookiness, you don't need much. All you'll need is some speakers and a Raspberry Pi. For the Raspberry Pi, this would be a basic setup. I did a headless install with Raspberry Pi OS Lite 32-bit. I'm not gonna walk you through that here because I do have other videos showing you that. Check them out somewhere around here. So with my Raspberry Pi powered up, I'm gonna go ahead and plug in my speakers into the audio port. There we go. And I wanna log into my Pi. I'll go ahead and get SSH'd in. And we'll start a new Python script, nano, piscareaudio.py. And first we'll import a few things. We'll import time, and we'll also import Pygame. This is what will actually allow us to play the sound. And here's the code. First we'll use Pygame, pygame.mixer.init with open and closing parentheses to initialize it. We'll then set a variable called scary sound and have that equal this, pygame.mixer.sound with a capital S, and in parentheses, we'll specify our sound. This will be the file that you have in your Raspberry Pi that will play. Now you will need a file. I've got a zombie screaming, which is awesome. It's in the OGG format, the OGG, because I found that played pretty nicely with the Raspberry Pi. It should be able to play WAV files, but if you have a problem, just convert it to OGG with something like Audacity or Adobe Audition. And then we can also set our volume real quick. I'll do pygame.mixer.sound.set_volume, and I'll say set, and in parentheses, I'll specify scary sound, and set the volume to 1, which I think is 100%. Yeah, just like loudest you can go, because you want that, don't you? And now we're ready to play our sound. We'll simply do scary sound.play and parentheses. So to keep it simple, we'll just do time.sleep for 5 seconds. That's it. Control X, Y, enter to save, and we'll run our script. This is gonna be loud, I'm warning you. Ready? Here we go. How awesome is that? Now the question you probably have is, how do I trigger this? How can I scare my family and trick-or-treaters? Of course, that's what you want to do. You could use a motion sensor, which I'll show you how to do here in a moment. But if you don't have that, and all you have is a Raspberry Pi and some speakers, you can use your you can use your phone. Like, check this out. On the iPhone, they have an app called Shortcuts. If you're not using that, you're crazy. It's so cool. Here I'm going to add a new shortcut, and I'll click Add Action, and I'm gonna search for SSH. And there it is. You probably already see where it's going now. Run script over SSH. I'm gonna select that. And here in the script box, I'm just gonna run with Python 3 my Piscare audio script. Then I'll enter in connection information. How do you get to it? Login info. And that's it. So now, with one button press, you can scare the living daylights out of some people. Watch, I'll do it again. How awesome is that? Now keep in mind, as I show you more stuff in this video, we can do that. Or we can trigger with some other stuff that don't involve us. I'll show you that too. So now time to play with our relay. So what I want you to do is unplug your Raspberry Pi, power it off, let it be dry like this. I don't know why I said dry. And we're gonna grab some DuPont wires. I recommend buying a set with an assorted bunch of wires. And first we're going to use a female to female DuPont wire. We'll need 3 of those suckers. Notice on the other side of the relays, we'll have some pins. On the far left, we'll have ground. On the far right, we'll have VOC. Now yours may be smaller. You may have a 2-terminal relay. I have an 8-terminal relay, but it'll work the same. We're gonna work with the ground pin first on the very far left. Go ahead and plug that in. And then referring to our GPIO pinout diagram, we're gonna plug this in on pin 39, one of the ground options. We'll grab another female DuPont wire, plug that into VOC on the very far right, and on the Raspberry Pi, we'll plug that into pin 2, which is 5-volt power. So currently, the Raspberry Pi is providing a 5-volt current to power our relay. Now I'm gonna grab another female DuPont wire, and on the relay, I'll plug this into is it INI? Yeah, oh no, IN1. And then on the Raspberry Pi, I'll plug that into pin 37. It's this pin, IN1, that will trigger the first relay, either opening it or closing it, connecting the wires and disconnecting the wires. And notice you'll have an IN for each terminal on your relay. Now what do you say we test it out? Let's go ahead and plug in our Pi, power it up, and SSH into it. Once I'm logged in, I'll start a new Python script with nano, naming it scarepy.py. Shebang! Did I scare you? Look, come here closer. Look, it's right here. Look, it's right there. You see it? All you gotta do is grab it. Come here. All you gotta do is grab it right here. Millie, come here. Millie. And we'll first start with importing things. Now the most important thing we're going to import, is the Raspberry Pi GPIO library. So we'll do import rpi.gpio as GPIO. And actually that's all I care about right now, because we're just testing. Next we'll set our GPIO mode with gpio.setMode, and in parentheses we'll say gpio.board. And all that's doing is telling it what numbering system we're going to use for our GPIO pins. Next, we'll set a variable. I'll name it relay. And I'm going to have this equal the pin that we plugged into our Raspberry Pi, the one we used, which is 37. If you used a different one, obviously put that in. Now we're going to tell the Raspberry Pi to use that pin as an output. We're going to be outputting data, sending an electrical signal down that wire. So we'll use the command GPIO.setup, and in parentheses we'll say our variable relay, pin 37, and we'll say GPIO.out. Now we're almost done. All we have to do now is put in some code to make it open and close, or connect the wires and disconnect. And actually, I lied about importing. I do want to import one more library. We'll import time, because you always need more time. So next we'll do GPIO.output, because we are outputting signal now. And in parentheses we'll say which pin we're going to output on relay. And we'll tell it we're going to go GPIO.high, which in the case of our relay is telling it to open up, do not connect the wires. And with the next command, we'll tell it to go low. .low, which will close it, connecting the wires. You'll actually hear it click when we try it here in a bit. And then we'll put it to sleep for a second. Time.sleep. We'll do 2 seconds. And then we'll do GPIO.output once more, and we'll do it high, opening it back up. Okay, that's our code. Control X, Y, enter to save with nano. And then I'll run my code with Python 3 scare pi.py. And let's see if it works. Hear that click? And close. Let's do it again. Ah, love that. It's so cool. Put your finger on it. You can feel it. Connecting and closing the wires. Now, if you haven't already, let's go ahead and connect to Halloween Prop and see how this will actually work. I'm gonna grab our guy from earlier. Oh, sorry, didn't mean to hurt you. I'll take that Try Me wire. Where are you? There it is. And actually, I gotta strip it a bit more. Expose some more wire. I'll be right back. Got it. God, this is kind of hard to maneuver this guy. Okay, so now on my relay, looking at K1, which is the first terminal. I'm going to unscrew the first 2 terminal holes from the left. I'm gonna plug in one of them, and I'm gonna put one of the wires inside, one of them, screw that in to make it tight, and then do the other one. So now, if I run my Python command once more, let's see what happens. Oh shoot, the wires came out. Make sure they're tight. Dang it. All right, now this should be tighter. Ready? Let's try it out. How cool is that? And often you can turn them off, because if you do the Try Me button again, it turns it off. Ah, isn't that cool? Ah, that's magic. So that right there is the baseline on how we're going to trigger our Halloween props. And actually, fun fact, that's how most haunted houses, if you're a fan of haunted houses like I am, will trigger their props. But I guarantee you they're not as sophisticated as us using Python. Actually, I know because I've toured these and talked to the guys. We're more advanced.
Snack.
Give me a snack.
You're in the way of the camera. It's not gonna hit you.
So now it's pretty cool that we can trigger it with Python. But oftentimes you want to make this automatic. You don't want to be there. You want to scare everyone even when you're not there. Now it's time for the motion sensor, and this thing is nuts. So first let's get it wired up before we program some Python. I'm gonna grab 3 female to female DuPont wires. Now looking at my motion sensor, I know the very left pin is for ground. So I'll plug that first one into ground, and I'll plug the other end on the Raspberry Pi into pin, what number is that? Pin 6, which is another ground pin. And then grabbing another DuPont wire, on the motion sensor I'll plug this into the very far right pin, which is for power, and we'll plug the other end into pin 4 on the Raspberry Pi, which is also a 5-volt pin. So that got our motion sensor powered up. Now the middle pin is the data pin. I'll take my third wire, plug it into the pin on the sensor. I should have did the middle one first. This is hard. And I'll plug the other end into pin 35 on the Raspberry Pi. All right, now time to code. I'm gonna start a new script just to test. So I'll do nano motion test.py. Just like the relay, I'm going to import the GPIO library by doing import rp lowercase i.gpio as GPIO. I'll also import time, and that's all I need right now. And just like before, we'll set our GPIO mode, GPIO.setMode, GPIO.board, and then we'll set up our pin for our motion sensor. Now this will be a bit different. So let's first assign our pin. We'll do a variable called motion and have that equal, what was the pin? 30, remember? 35? Yes, 35, I think. And then we'll set that pin up as input rather than output, because the motion sensor is going to be sending data to the Raspberry Pi. So we'll do GPIO.setup, and in parentheses, we'll specify motion, our pin, and we'll say GPIO.in, all uppercase. And now with it set, we can test it. Then we're going to do a while statement. While true. This will run forever unless we stop it. I'll hit enter, tab over, and I'll set a new variable real quick. I'll just call it something, and I'll have that equal GPIO.input, and in parentheses, I'll say the variable motion, which is our sensor. I'll hit enter, tab over once more, and I'll say print something. And what this will do is actually print what information or what data the motion sensor is sending to the Raspberry Pi. And then just after that, I'll hit enter, tab over, and do a time.sleep for 1 second. So it'll print it every second. Hit Control X, Y, enter to save. Now let's run our script. Python 3 motion test.py, ready, set, go. Okay, so right now it's printing 0, which does mean there's no motion. But now, if I wave my hand in front of it, look at that, 1. 1 means motion detected. Look at that. And that's how this works. So now that you have it wired up and you know how to program it, the possibilities are endless. So now what I want to do real quick is set this up to trigger my buddy over here. Let's do that right now. I'll do Control C to close that script. And let's take everything we just did with the motion sensor and add that to our relay script. I'll do nano scarepie.py. I'll add all the information for our motion sensor. I'll take all the stuff out at the bottom real quick. And I'll do another while true statement. While true. And then I'll put an if statement in here. Now, if all this is like new, you're like, whoa, what's Chuck even talking about? What even is Python? I've got a Python series where I cover pretty much all of this. So check it out over here somewhere. It'll fill in the gaps on some of the stuff I'm doing right now. But don't leave yet. I'll walk you through everything right now. No big deal.
Go grab me that waffle. I need to de-stress.
So we'll do if something equals double equals 1. So we know that it's going to print 0 when nothing's there, 1 when something is. So we're going to say, hey, when something's there, when 1 happens, do this thing. So colon, enter, we'll tab over twice. So we're nested under our if. And this is where I'm going to trigger my buddy over here. What should I name him? Spencer. His name is Spencer. I don't know why it just came to me. I'll do GPIO.output relay. I'll first put him high to make sure it's open. And then just under that, I'll put him low. I'll leave it open for 2 seconds and then I'll close it. That way it gives this guy time to realize he's been triggered. And that's it. I will unnest myself and do a time.sleep. And now this time I'll do 0.5 seconds. And that's it. So let's save it. Control X, Y, enter to save. I'll run our script, scarepie.py. So right now, no motion, right? Nothing's going on. Motion! How cool is that? Motion. I'm gonna stay still. So right now I'm not moving. I'm not moving. If I move, I love that. Now what do you say we add in our sound? Just under where I triggered the relay, I'm gonna add all my sound information here. I'll import Pygame. And then just under when I trigger the relay, I'm gonna play the sound. That's it, let's test it out. Control X, Y, enter to save. Run our script. Okay, no motion right now. If I move my coffee cup, I love it. That is pure magic. Let's do it again. Okay, that's enough of that. Now let's talk about the Raspberry Pi camera. There are actually a ton of different cameras you can get for the Raspberry Pi. Here I have the Pi Camera 2, but I also bought a couple others and they all work great. So now our goal here is to capture the scares we perform with this guy, or whatever guy you have. So first we'll get it plugged in. You're gonna plug it into the slot that's right next to the audio cable, or the audio jack. The one closest to the USB and Ethernet port. You're gonna plug in your ribbon cable with the blue tape side facing the USB. Make sure you lift that latch, slide that cable in there, and then close the latch. It's kind of delicate work. Bam, got it. Okay, now just a little bit of work to set it up. And now also, if you had your Raspberry Pi up and you start messing with that, it just kind of breaks your Pi for a second. So go ahead and do a reboot if you have that issue. I'm gonna do that right now. Actually, it won't even reboot. I'm just gonna unplug it. Bye. And wait for it to come back up. Once you're back up, we're gonna do something kind of weird. We're going to enable legacy camera support on your Raspberry Pi. To do that, we'll do sudo raspi-config, and then we'll scroll down to option 3, interface options, and then I1, go ahead and hit that. We'll hit yes to enable legacy camera support, okay, tab over to finish, and yes to reboot. We're doing legacy because it plays the nicest right now with Python, and that's what we're using. When you're back up, let's do a quick test to make sure your camera is working. I'll use the command raspi still. This will just take a quick photo with your camera, so make sure you smile. We'll do a -O, and then we'll name it test.png. Ready, set, go. Let's take a look at it. Beautiful. So mine works. Let's also do a video test. The command will be raspi vid. We'll do a -O. We'll name that test.h264. And because it's a video, we'll have to set the time, so we'll do a -T for 10 seconds, which is 10,000 milliseconds. Ready, set, go. Now right now it's in that H.264 format. We want to convert that to MP4 so we can play it everywhere else. For that, we'll need a tool. You can install this real quick right now. Sudo apt install, it's called GPAC, I believe. Just like that, we'll do a -Y to confirm that. And once installed, we'll do this command. MP4 box, we'll do -add, specify our file, which is test.h264, and then the file we want to name it as test.mp4 or convert it to. Ready, set, go. Done. That was easy. Oh, almost, yeah, it's done. Now let's take a look at that. Perfect. Little motion sicknessy, but it works. It's actually not bad looking either. So now that we know the picture works and the video works, we can harness this to do something pretty cool for Halloween. Now to use it with Python, we will need to install one more thing. Just one command, sudo apt install python 3-pycamera. And that's it. So now I'm gonna add this camera to our existing scarepy script. Nano scarepy.py, and I'll do from pycamera import pi C camera. And then just below that, I'll set some information about it. Now keep in mind, I'm gonna have all this documentation, all this code in a link below that you can check out and just practice with. And it won't be as messy as this. Let's go ahead and set up our camera real quick. I'm gonna set a new variable called camera and have that equal the function pi camera, capital P, capital C, parentheses, and then I'll set the resolution and frame rate. Camera.resolution equals, in parentheses, 1080 by 1020, and then camera.frame rate. And I'll have that equal 30 frames per second. Now that's pretty much all we have to do to set it up. Now all we have to do is tell Python to record it when we sense some motion with our motion sensor. So let's go to our while true statement at the bottom here. So here we have it to where if we sense motion, if something equals 1, then do all this stuff. We want to have our camera start recording as well when something is 1. And I want that to happen first. So I'm going to do that right after something happens. So just under our if statement, I'm going to nest it over, and we'll call our variable camera.start_recording, and then in parentheses, we'll specify the file name. Now we could just hard code it right now. Actually, we will do that just for testing. Scared.h264. And then what I'll also do is time.sleep for 2 seconds to give it time to start recording. And then when everything's said and done, the very last thing we'll do at the very end is camera.stop_recording, and then opening, closing parentheses. And that's it. Like, we have the camera set up, and it should work when motion's triggered. Let's do Control X, Y, enter to save. Python 3 scared pi to run our script. Ready, set, go. Okay, let's test it out. So let's cause some motion, some commotion over here. Bam, motion detected. It should start. Freaking A. So now if I do ls, we should have a scared.h264 file there. If I convert that with MP4 box, we can watch it right now. Which is just me looking crazy all the time. Now there are a couple of house cleaning things we can do to make sure things run smoothly. For example, we may want a different file name created for each video recording so it doesn't keep overwriting itself. Because right now it's going to overwrite scared.h264 every time you do this. So we can define a file name. And what I want to do is do a file name with a timestamp on it. That'll make sure it's unique and it's helpful. So first I'll import at the top here, date time. Actually, I'll do from date time, import date time. and I'll create a new variable called current, and I'll have that equal datetime dot now, opening closing parentheses, which will just get the current date and time. And then down here in our if statement, before we start recording, I'll define the file name. So I'll say file name equals current, and actually I want current to be a string, so I'll wrap that in a string function, str, and then I'll add that. And what I'll do is I'll call this PyScare. I'll create the string PyScare. Then I'll add this to the variable current that we just created. And actually I need to convert that to a string. So I'll do str, the string function. And then I'll add that to the file extension .h264. And then I'll change our camera.start_recording to be the variable file name. That should do it. So let's Control X, Y, enter to save. Let's run our script. If it launches. Done. If I do ls, there's our new video right there. Now it's kind of messy, we could do some things to fix that, but that works. Now what you've seen so far, I would say is like a basic level of spookiness. It's still very cool. I mean, triggering it with motion, and actually you can do other triggers. Like I have one trigger that's a vibration sensor, so I'm gonna put that inside a candy bowl, and you know, when kids reach for candy, something happens, which actually leads me to the next thing I'm doing. The next level of spookiness, and that's where I decided to buy some legit haunted house Halloween props. This isn't stuff you can buy at Home Depot and Target. So I found this website called frightprops.net or .com or something, but it's amazing. It's not cheap, so you have to love Halloween. But I was drooling, so I bought a couple things, all powered by pneumatics. So I bought a prop launcher that'll do this. And then I also bought an ankle blaster that will blast air. And of course I need to power this with air, so I needed a really heavy duty compressor, so I got one. Now what's interesting is these are all controlled by a Raspberry Pi-like device called a Peekaboo. Peekaboo, it's a neat name, but it's basically a dumb version of a Raspberry Pi. Now what it does built in is pretty cool. They actually have a built-in relay, and it does provide power to the props. So I still use the Peekaboo, but I connected the Peekaboo to my Raspberry Pi. That way I can control all these Halloween props, the legit haunted house props, with Python. And this is something I don't think a lot of haunted houses do. So if you're watching this haunted houses, let me help you, because your stuff can get a lot more complex and a lot more crazy. So what you're about to see here, and you've probably seen throughout this video, sprinkled throughout me scaring people, is a lot of Python fun, powering a bunch of different props, recording videos. I got a little crazy this year. I spent way too much time on this, but a special shout out to everyone who's helped me do this. My wife for dealing with my craziness, buying all these props, and helping me decorate. My entire team, so wave team, say hi. And Luke, my kind of handyman extraordinaire, he built me a coffin. So if you know a guy who can build you a coffin, that's a friend. Thanks, Luke. So anyways, I'll probably have a few more scares I'm gonna show you right now, but that's my Halloween special this year. Was it spooky? I hope it was. Oh.